Alright, and welcome to multiplying complex numbers. Now take a look at the number, that's going to sound weird, take a look at the number a plus bi. You'll notice that a does not have an I term, so it is a real number, and our bi term does have an I, so it is imaginary. Okay, so we have a real and an imaginary number. Now this actually has a name. We call these complex numbers. So they have components on the real axis and components on the imaginary axis. Now, what does that mean for you? Well, we're more so just interested in multiplying these today. What does it look like to multiply two complex numbers? So let's do, something like 2 minus 6i times 3 plus 4i. And what will that look like? Well, the first thing I would ask you to do is I would ask you to utilize the box method. Remember, we can draw a box, and let me use different colors here. We can say, this factor, 2 minus 6i, or this complex number, should I say, will go on the top, and this other factor, or this complex number, will go on the left side. Now from here, we're simply going to multiply into each box. We know that 3 times 2 is 6. I continue to bring the 2 down. 2 times 4i is going to be 8i. Remember, these are all the rules that we're building. This is what we're building up to. I bring the 3 over more. 3 times negative 6i will be negative 18i. And lastly, I drop the negative 6i down, and negative 6i times 4i will be negative 24i squared. Remember, I times I will give us I squared. Now, what's it going to look like when I write all this out? Well, we said we have 6 minus 18i plus 8i minus 24i squared. Now, what's going to happen here when we go to simplify this? We really have to do kind of 3 steps. Step number 1, I want you to remember the identity I squared is equal to negative 1. And what does a negative 1 do? It simply changes the sign. So we're always going to cross out our I squared and make a negative into a positive. We now have 6 plus 24, which combines to be 30. That's our second step. Now from here, what is negative 18i plus 8i? Well, we know that there are more negatives than there are positive, so our answer is negative. And 18 minus 8, when they're different signs we're subtracting, 18 minus 8 will give us 10i. So when I multiply these two complex numbers, in this case, I get another complex number, 30 minus 10i. All right, let's move on to our next example. Now, example 2, these are not complex numbers because there's no imaginary numbers, but they are definitely still irrational numbers. And so I want to go ahead and practice this before we move on to our third example. And by the way, the third example is the most important example of this video, but walk with me as we go through this one right here. So we still have the same thing where we want to use the box method. And on top, we can put 3 minus 2 square roots of 3. And, just to distinguish this here, on the left, we can put 4 minus 8 square roots of 2. So what's it going to be when we multiply these things? In fact, you know what? I'm sorry. I'm going to go ahead and make this just a little bit larger just so y'all can see it better. My apologies. So we'll draw our box, and we'll put this top number, 3 minus 2 square roots of 3. And then going down on the left, let's use this 4 minus 8 square roots of 2. Now, what will it look like to multiply each one of these? We know that 4 times 3 is 12. We know that 4 times negative 2 square roots of 3 will be negative 8 square roots of 3. Remember, we multiply the coefficients. Here we have negative 8 square roots of 2 times 3, which will give us negative 24 square roots of 2. And lastly, we have negative 8 times negative 2, which will give us positive 16 square roots of 2 times 3, which is 6. Now from here, what's it going to look like to write all this out? We'll write 12 minus 8 square roots of 3 minus 24 square roots of 2 plus 16 square roots of 6. And in fact, there's nothing here that combines. Remember, the square root of 3 can't combine with the square root of 2. The square root of 2 can't combine with the square root of 6, so on and so forth. And so this would actually be your answer for example 2. All right, now let's move on to the most important problem of this video. Okay, here we are on example 3, and I want you to notice we have 8 minus 2i squared root of 3 times negative 4 plus 3i squared root of 3. And there's one important distinction I want y'all to note at the beginning of this example. We're going to do this example where our radicals are both the exact same, square root of 3 times square root of 3 at some point. Now in the fourth example, I'll repeat this, this level of problem where the radicals are different. So I kind of misspoke earlier. Examples 3 and examples 4 are in fact the most important examples. Now let's go ahead and set up our box method. Let's call this first term 8 minus 2i square roots of 3. And let's go ahead and use this nice purple color. And let's go ahead and write this negative 4 3i square roots of 3 over here. Now when we multiply these, guys, you have to take these in steps or you have to multiply them in parts. Negative 4 times 8 will be negative 32. Here, negative 4 times 2i square roots of 3, or negative 2i square roots of 3, we have a negative times negative, which is a positive. 4 times 2, which is 8. And remember, it's really 4 times 2i, so that becomes 8i. And since there's no other radicals there, we simply add on the square root of 3. Now from here, we have 8 times 3i. We know that that is 24i. And we tack on the square root of 3. And lastly, what happens when we multiply 3i square root of 3 times negative 2i square root of 3? Well, in parts, 3 times negative 2 is negative 6. I times I is I squared. And the square root of 3 times the square root of 3 is the square root of 3 squared. So remember, guys, in this example, we're utilizing every single one of the 3 parts from our 3 previous sections. So let's go ahead and write this out. We have negative 32 plus 8i square roots of 3 plus 24i square roots of 3 minus 6i squared, the square root of 3 squared. And let's go ahead and start simplifying this from left to right. I know that the first thing I want to do is I want to keep my negative 32 because I don't really see any other real numbers just yet. I know that 8i square root of 3 plus 24i square root of 3, they both have this I square root of 3. In fact, let's use a different color here. They both have these I square roots of 3. So we'll do 8 plus 32, which will be, 8 plus 24, which will be 32i square roots of 3. Since they are like terms, they can be combined. Now let's go ahead and do one more thing over here. See how we have this I squared? Well, guys, what's our rule? When we see I squared, we cross it out and change the sign. So our 6 goes from a negative to a positive. So I can write plus 6. And here, we have the square root of 3 squared. Well, remember, square roots and squares cancel. It's really just 6 times 3. So when we simplify this one step further, we have negative 32 plus 32i square root of 3 plus 6 times 3 is 18. And you'll notice we can now combine our 2 real numbers together. Negative 32 plus 18 will, of course, give us negative 14. And that will be negative 14 plus 32i square root of 3. Now, if you're confused by that, I'll be honest, it would probably help you out if you would go back and rewatch the first 3 videos. If you watch every example in the first 3 videos, it will prepare you for this problem. If you didn't, well, you need to go back right now. Otherwise, you're going to be very confused. All right, let's go on to our fourth and final example. Okay, for our example 4, we're now going to multiply 3 minus 2i square roots of 5 times 6 plus 8i square roots of 7. Now notice, here we have the square root of 5 and the square root of 7 embedded. So this is a case where our square roots, our radicals are different. And let's see how that goes ahead and plays out. So in purple, I'll write this, 3 minus 2i square roots of 5. And then over here in orange, let's go ahead and write 6 plus 8i square roots of 7. And what's this going to look like when we multiply everything? Well, we know that 6 times 3 is clearly 18. I know that 6 times negative 2 will give me negative 12i. Remember, the I just gets tacked on. I square roots of 5. And right over here, we have 8I times 3. That will be 24I. Square roots of 7. The square root of 7 just gets tacked on. And lastly, this is the tricky one. Let's take it by parts. 8 times negative 2 is negative 16. We have I times I, which will be I squared. And we have the square root of 7 times the square root of 5, which will actually be the square root of 35. Okay, let's write everything out. We now have 18 minus 12I square roots of 5 plus 24I square roots of 7 minus 16I squared square roots of 35. Now you're going to notice something here. We have the square root of 5, the square root of 7, and the square root of 35. None of those can combine. The only thing we can do here to simplify this is to cross out our I squared, which makes the 16 go from a negative to a positive. Now you'll also notice that once the I cancels out, this is now a real number. So if we're going to write this correctly, we actually want to write 18 plus 16 square roots of 35 minus 12I square roots of 5 plus 24I square roots of 7. We always want our real numbers to come first, and we always want our imaginary numbers to come second. Okay? So this is, in fact, in and of itself, a form of a complex number. Alright? I hope this helps. Good luck, and I'll catch you guys later.